Parallel lines cut by a transversal. So you're always going to have a picture that looks similar to this. It may be in a slightly different orientation, but it will always have parallel lines to start with, which means we have two lines that are going in the same direction. And these little arrows right here are telling you that they are parallel. That's a little notation that says it's parallel. It might say in the instructions that it's parallel, so make sure that you're reading that. And then this is the transversal. So if you were to say something like, I traversed the desert, that means that you walked across the desert. So a transversal, to traverse, goes across the two parallel lines. So it's basically a line that goes across the two parallel lines. That's all that it means. So this is parallel lines and a transversal, so a line that goes through it. Now, when you have a parallel lines cut by a transversal, there's some very specific things that you come across. So one of them is corresponding angles. So corresponding angles, kind of like these two that I have highlighted here, are on the same side of the transversal and in the same position on each line. So if you think of this as a cluster of angles, there's a cluster of angles on each of those lines. This one's in the upper right and this one is in the upper right. So maybe you would have two angles that are in the bottom left, bottom left. So think of it as a cluster. So it's in the same position on the line. So it's above the line on the right side of the transversal, or it's below the line on the left side of the transversal. Now the thing about corresponding angles is they are congruent. So they're always the same exact size. Alternate interior angles are in between the parallel lines and on opposite sides of the transversal. So in between the parallel lines is the word in where the word interior comes from. Interior means inside, like the interior of your bedroom is the inside of your bedroom, okay? And then alternate meaning different sides. So that's where the opposite sides come from. So one's on the left, one's on the right of the transversal, and they're in between the parallel lines. So that's where these two are alternate interior angles. And these two would also be alternate interior angles. They're on the inside of the parallel lines on opposite sides of the transversal. Now the thing about alternate interior angles is they are also congruent, same exact size. Alternate exterior angle. So if you notice the difference between the previous type and this one, the only difference is the word exterior. So now the angles are on the outside of the parallel line, so you can see they're outside, and they're still on the opposite sides of the transversal. So that's where the exterior is on the outside, alternate is on different sides of the transversal, and they are also congruent. So you could also come across these two angles, upper right and then the bottom left. Those are also alternate exterior angles. They're on the outside of the parallel lines and on opposite sides of the transversal, and they are congruent. Last type is consecutive interior angles. They are on the same side of the transversal and on the inside of the parallel lines. So the interior word comes from it being on the inside of the parallel lines. The consecutive comes from it being on the same side. So it's not opposite sides, it's the same side. So you can see that these two right here are both inside the parallel lines and they're both on the left side of the transversal. So the other pair would be on the right side of the transversal on the inside. Now these are not consecutive, they are supplementary, which means they add up to 180 degrees. So be very careful. These are the only ones that are not congruent. So we're going to use those names to name a couple of things that we have here. So I have this lovely picture on the left, and I have just randomly named angles 1, 2, 3, 4, 5, 6, 7, and 8. And we're going to name their relationship. So if I were to look at angles 1 and 5, angles 1 is here, angle 5 is there. So if I considered this cluster at the top and this cluster at the bottom, angles 1 and 5 are both in the upper left-hand corner of those clusters, which means they are corresponding angles. because corresponding angles are in the same spot, same exact place on both of those lines, so corresponding angles. If I were to look at angle 2 and 7, so angles 2 and 7, so I have 2 and 7, so they are both on the outside of my parallel lines, and they're on opposite sides of my transversal. So those are going to be alternate, that's the opposite sides of the transversal, and alternate exterior, because they're on the outside of the parallel lines, angles. And those are going to be congruent. 4 and 6, so angle 4 and angle 6. So those are both located inside of the parallel lines, and they're on the same side of the transversal. So they're going to be consecutive, because they're on the same side, consecutive, and interior, because they're both on the inside of the parallel line, angles. 5 and 8, angles 5 and 8. Now these two are on the same cluster, so this is not a word that we just went over right now. Those two are on opposite sides of two crossing lines. So if you consider that as that one line with the transversal, those are on opposite sides of crossing lines. So those are just vertical angles. That is a word we have learned previously. If we were to look at angle 2 and 4, again, those are in the same cluster. So all of these previous words for parallel lines cut by a transversal, there's one angle in each of the clusters. So that is not going to be one of those words. However, those two are on a line. So I could either say that they are a linear pair because they are on this line together, or I could call them supplementary. I'm going to call them supplementary. You can write both if you'd like to, because they both are linear and supplementary. Angles 4 and 5, angles 4 and 5. Now these two are in opposite clusters. So this is going to be some sort of a word. So they are both on the inside of the parallel lines, and they are on opposite sides of the transversal. So they are going to be alternate, because they're on opposite sides of the transversal, and interior, because they are both on the inside of the parallel lines. So now what we're going to do is we're going to write a couple of equations to solve for x given some information. So here I have two parallel lines cut by a transversal. I'm told that angle 1 is 74 degrees and angle 2 is 9x plus 11. Now if I look at where they're located, angle 1 and angle 2, and if it bugs you being sideways, feel free to turn your paper, rewrite it to be in a different orientation. That's completely fine. So if I were to look at these, they are on the same side of the transversal, and they're both in the upper right hand corner, or the top I should say, of that cluster. So they're in the same position on the parallel line. They're above the parallel line, which makes them corresponding. Now the thing that I know about corresponding angles is they are congruent. So if they're congruent, then their degrees have to be the same. So what I can do is write an equation where these two degrees are the same. So I have 74 equals 9x plus 11. So I can now solve this. I'm going to subtract 11 from both sides. I'm going to get 63 equals 9x. I'm going to divide both sides by 9, and I'm going to get x equals 7. So knowing that they were corresponding angles, same side of the transversal, same position on the parallel lines, I knew that they were congruent, and I can write an equation where they equal each other. Now if this was my picture, and again my parallel lines are going in a slightly opposite direction of what our original pictures look like, feel free to rotate it if you want to. We have our transversal, which is this one right here, and our two angles are on the inside of the parallel lines, And they are on the same side of the transversal, which means they are consecutive interior. Consecutive interior angles. Now, one of the things we know about consecutive interior angles is they add up to 180 degrees. So if the measure of angle 1 is 13x minus 2, and the measure of angle 2 is 4x minus 5, then if I were to add these together, they should equal 180 degrees. So my equation becomes 13x minus 2 plus 4x minus 5 equals 180 degrees. So if I solve this, I have 17x minus 7 equals 180. I'm going to add 7 to both sides. 17x equals 187. And then I'm going to divide both sides by 17. And I'm going to get x equals 11. So I figured out what x equals. And if I wanted to know what one of the angles were, I could go 13 times 11, and then I could subtract 2. So 13 times 11 is 143, and 143 minus 2 is 141 degrees. Now remember, this picture is not drawn to scale.